Hey guys and girls, how's everybody doing? So nice to be back, just doing something. Hope you guys are doing great. Today's video is going to be really simple, just a really simple little app to have fun and learn some SFML and C++. I'm sure a lot of you know how it works already, but this is for the people who are just pure beginners, just want to do some simple apps and games. I know that series, the old one, has a lot of people following it, and this is basically the same. So just follow along here. You'll find the same kind of content, but much better in quality and split up in better ways, easier to find the code and so on and so on. So today's app is going to be really easy. I'm just going to show you a little demo of how that will look. Don't forget to drop a like, comment, and subscribe. It really helps out just to make these videos, put the time in. Just a like and a comment helps so much. So just remember that, guys. Please do it if you can. It really helps me out, and I hope you enjoy this video. So I just run the little app, and if I press B, it's going to pop up a bunch of buttons, and we're going to just click the buttons. That's it. There's no game. There's no point in that sense, but it will show you how to load a texture, how to change the textures, and how to click and get the response like this. The buttons don't do anything on their own, and the text is fixed to the texture. So it's not font per se, but we'll do that later. But just follow on along here, and you'll at least learn how to do these simple things. And then you can maybe implement this in some other application. So I'm not going to show you how to install Visual Studio, but I'm sure you can do that on your own. All you have to do is to install the Visual Studio Community 2022, and you should be good to go. I will show you how to make the new project though. So what you're going to need to do is click on Create New Project, Empty Project, and just name it whatever you want. I'm going to call it Button app like that. And I'm just going to put it wherever I want. So I'll just put it here. Once that is created, it will be totally empty. Now there is a video which shows how to link SFML. I'm not going to show you that here because the video is already there. It'll be just double the effort. So I'm just going to show you that video. All you have to do is to go to YouTube and search for my channel and find this video. I'll linking it, and you should be good to go. And it's a good video. There is a short version as well here, which I'll link to, and just really short, super simple, maybe a minute, I think. Shows you how to do it, so it shouldn't be too complicated. If you're on Linux or Mac, you can go to the SFML homepage, go to Learn, Tutorials, and then you'll find the different sections here. So SFML and Linux, SFML and Mac OS X or Xcode, and just the different ways to do it here. So you have it right here. But if you're on Windows, I have a video out for that. So what I did now was I opened another project where I have SFML linked, and this project is going to be part of the Git repository. So you'll find all the textures, all the code there. It'll be really easy to do. And to find my Git, all you have to do is to search for my name and then 90 afterwards. So I changed my name from the link. There might be an old link circulating, but that link doesn't work anymore. So just search for my name here, and you'll find all my repositories. I'll put that up here so that you can find it and just download all the code. And the way the code base works is that there will be a folder, and in the folder, you'll find all the DLLs and everything. And then you'll find each application that I make, you'll find it here. And you just download it, and then you can put the main files in here. I'll make a tutorial on that as well and explain it in the repository itself. So don't worry, but just know that you'll find everything here. So the first thing we're going to do is we're going to create all the files that we need. I'm going to go ahead and create a main file, because that you always have to do in C++. This is your main entry point. And I'm just going to make a main that is very default. So I'm going to include iostream int main return 0. And like I always say in these videos, I expect you have some C++ knowledge from the start. So I'm not going to explain everything, but you'll know mostly what I'm doing in SFML will be where I give you the explanations. The C++ part, I expect you should know most of it, but if you don't, it's still going to be fairly simple. So I just basically made a very simple main function. It's just going to print this out to the terminal, and we'll just see so our main is working, and it works. It prints that out. Perfect. Now, just a few things, disclaimers. Make sure when you link SFML, everything that you're running on x86, because we're going to be in any project that I do, I always include the 32-bit version of SFML. So don't make sure it's not on 64. Make sure it's on 86, because that's what you're going to have been linked. Now that we know the main function works, let's just quickly make a class here. So I'm going to go right click on my source files, add and class, and I'm going to call this class button, and it's going to create the header file and the CPP file for me. No base class, not inline. Click it in, and you'll have two files pop up. Perfect. Now, obviously in this video, the most important part is the button class, and we're going to be starting off with that because this header file is basically going to allow us to put a blueprint out of what we want the button to do. So I'm going to start off by just including everything I need. And then we're going to flesh out the button class header. So SFML system.hpp, you can go into these files if you want and see what they include. If I control click it, you'll see what kind of things are in here. So it's basically including these things. And we want the vector 2, for example. So that's why I'm including that. And just control D on that line and you'll duplicate it. And we'll change this to graphics, and right click that as well. And you can see whatever this includes. Once you've included what you need, I'm also going to include IO stream here just for some debugging. Forgot about that. But once you've included everything you need here, we'll start working on the button class. So I'm going to start off by splitting this up into private and public. Sorry, it's a little hard typing with my eyes down here, but should be fine. So what we know from start, what a button is going to need is, if you just think about it, a button has a shape, right? It has a shape, some kind of a rectangle, circular, whatever, some kind of a texture on it, some shape, and it has a way to click on it so you can see it. It has colors and a font and whatever. We're not going to work with fonts here, but maybe colors, so we can try that out. So just a few things. And it has a state, right? It has some type of a state where you can click it. Either it's idle, it's clicked, or it's hovering. So these things we're just going to implement here. Let's start off with the shape. So for the shape, I'm going to use a SFML class called Sprite. It's a really good class which allows us to add textures to some object here, and it will turn into a form basically. So we'll have a texture, it will have bounds. You'll be able to click it, you'll be able to do things with it, move it around. So the sprite itself is really powerful, and we're just going to call this shape. You can call it whatever you want. You don't have to stick to what I'm doing here. And now I'm going to add some colors, because we're going to try out colors as well. So I'm going to name these color idle, color hover, and color press. So we have our 3 colors. Now I know that we're going to use 3 textures as well. So I'm going to add 3 textures with the same names just about. And the texture class is also very powerful. It can hold a texture, and basically it's an image, but you can do some more things to it, manipulate it in different ways. And also remember that you can always read about these on the SFML homepage. So I'm going to add 3 with the same type of names here. So idle, hover, and pressed. So now we have everything we need for the shape almost. All we want more now is some type of a state, button date. And this is just going to keep track of where it is. Basically, if we want to use that later, for example, in a getter to get the state, is the button pressed? Is it hovering? Is it idle? Whatever. So now that we have the variables, member variables in place, what we want to do is to add a constructor. So I'm just going to add a simple constructor here and a destructor as well. Usually you don't have to define these destructors if you're not going to do anything with them, but I'll do it anyway. It's just a good habit to do that. Sometimes you want to put these to virtual and this and that. So I just always do that. And what we're going to need in the button, which I already know, is a way to click on. It will be a way to position it, create it at some position. So to know that, we're going to have to give it a position at start. And that's why I needed the vector 2. So SF vector 2F, and we're just going to name this mouse pos view. And I'm going to explain why I'm calling it mouse position view and not just mouse position, because in SFML there are different ways to calculate the mouse position, and I'll get into that when we get there. But for now, just know that we need a vector 2. So basically just a position where we create the button. And now I'm going to create just 2 getters, and this is just good for just the knowledge of having these. I'm not going to use these maybe, but we're just going to have them just to show you how to do it. So basically it's just going to get the state of the button, and that will be a Boolean, and I'll call it is press const. And this is usually how you create a getter, which is optimized basically in C++. Now, if you know about C++, you'll know that the compiler optimizes a lot of stuff for you depending on what you set it to, but it's still good to have the habit of doing this on your own so you know what's going on. So basically, we are returning a constant bool reference. And when you do a bool reference, it's not going to return a copy of a Boolean. Now, it's a very lightweight data type, so it doesn't really matter, but it's still a nice habit to have. So when you return a reference, you're not copying anything. You're just sending a reference to something. I'm not going to explain that in detail, but it's good that you read about it. And then the const here just means that we're not changing anything within this function. So this function will not change any member variable. It will just return something. And we're locking that by using const after the declaration here. I'm going to duplicate that, and I'm going to call this is hover. And now what we're going to do is we're just going to do the last 2. We'll do void update. And the update function is going to need to know the window that we're in, because we're going to have to click on buttons. And usually I don't like to do input within a class like this, you shouldn't do it. But in this example, for the example's sake, to make it a little easier to understand, we'll confine the clicking and stuff to this class. But when you're doing this on your own, try to send a position in here instead from outside to check if it's clicked or not, or just try to do it outside. And we'll have different tutorials showing you how to do that. This is just really simple, just to show you something. And then I'm going to do void render. Sorry, capital here is a bad habit from different programming languages, but let's go. So update and render. Now I said we're going to need the window here. So I'm just going to say SF render window, and I'm going to make this a const reference. So don't forget the reference symbol here and the const. And especially the window is a good idea to send it in as a reference because it's pretty heavy and you don't want to copy the window. You want the actual window from outside to be here as a ref. And the same thing for the render. Since we want to render this button or draw it to some type of a window, we need a window reference here as well. Now I'm going to show you a little fun thing here. We're going to use something called SF render target. And it's a good idea to use this when you can, because a window is a render target. This derives from this. So there are different targets that you can render to. So usually it's a good idea to just use this base class here instead of just sending the window, because then you're locked to rendering to the window. Maybe you want to render to a canvas instead or whatever, and you want to render to some other type of renderable target. Maybe you make your own, whatever. So it's a good idea to use render target. I like that. It's a good habit to have when you are not locked to using the window. If you have to use the window, then you do that. Otherwise, you can use target. So this is our button class. And now we're going to start to flesh it out. Now, before I show you the fleshing out of the button, I just want to mention where the textures are. So when you go into your project and you find the textures folder, this is where I'm going to put all the textures that have to do with that application. And those textures will be found within the game folder itself. So you're going to have to pull that out and the CPP files and the header files out to the project folder basically, and then it will work. But the textures, if you don't find them here, you'll have to go in and look in here. Now the name of this folder is wrong. I'll change all that, but just remember the textures will be here. So as I showed you just now, there are 3 textures and we're going to be using these. So we're going to have to load them in here as well as set some colors because we're going to be playing with that as well. So let's just get started. So what I like to do is I like to right or control click on these. Sorry, I like to right click on these or control dot, but just do these and create a definition of button in Button.cpp. So that will automatically create a definition for me. I'm just going to do that for all of these. So once you're done with that, you're just going to have a shell here. And we're going to start off with the constructor, since this is what's going to be called when we create our button. And I'm going to set all of our colors, starting with color idle, to a SF color and some type of a start. So I'm going to have a idle button as white and red. So I created 3 of these. Remember to change the name of these. So idle, hover, and press, and then set them to whatever colors you like. You can even make your own colors by doing SF color, and then in the parentheses, you can just give it any type of numbers here or integers basically. So from 0 to 255 by using it like this, but I'm just going to give it the predefined ones. Once you've done that, it's time to load the textures. So I'll just do that quickly. And for that, we'll use the function for the texture idle dot load from file textures, and then button idle .png. So this is basically just a way to load a texture from a file, just like it says, and it's relative to the source directory. So textures is right under where this file is, the CPP file for button. So it'll find it just by giving the folder name and the name of the texture. So I'm going to do this, and we're going to do a and copy this, and then do another and copy it again. Now we're going to change these. So instead of idle, it's going to say hover and press, and then we're going to change these as well. So hover and press. So just make sure that the file names are correct. You can double check that by going in here, hover, idle, and pressed. Good. And the end of it as well is PNG files. Perfect. Make sure you can see the file name extension so you don't have anything extra after these, but this should be. So if all of these 3 loads, I just want to tell the user that. Now this isn't really nice at all to load textures like this within a class. And you might be asking, well, why are you doing it? Well, it's a little easier to do if you're making a quick video like this. But if you're generally, when you're loading textures, never do it in classes like this. Do as I preach, not as I do. Okay. So just have these outside and send references to these in here instead. So I might have an array of textures, which I just send in as a reference here, and doing that costs almost nothing, and I won't have to reload these every time I create a button. That's just a lot of waste of memory. But for this example, just bear with me here. We'll do it this way, And in the next one, a little more advanced, we won't do it like this. So I'm just going to print out textures loaded and a new line. And then we're going to set the texture as well. So this shape.set texture, and we're going to set it to the idle because we always want a button to be in the idle state when it's created. This texture idle. Good. And sometimes the texture takes a reference, or the sprite takes a texture reference. And sometimes another object, for example, the rect takes a pointer. So then this might be red and you might be, what the hell is going on? Well, then you just have to give the address to the texture like this. But in this case, it's a reference, so you just send it in like this. Good. And of course, if the textures didn't load, we just want to do a std_cout textures could not load textures. Could not load textures. Now, of course, you don't know which one of these won't load, but that's a detail you can add if you want. I don't have the time for that just now. Now, just two more things to do. We want the button state to become something. And something I forgot to add earlier is an enum. So I'm just going to say enum button state, and we're going to add a few button states. And an enum is basically just an integer which you can access, which is with a set value. So a bunch of constants. So I'll call it idle, and then hover and press equals 2. So these are the different states that the button can be in. And it's good for us if we want to get that state. We'll get a number back and we can just compare that. Anywho, I'll set it to button. I'll set it to idle. Like that. Now, good idea with enums is to have some kind of a prefix here to just say what enum it is, or call the button state and then the enum you want or the value you want. But I'll just do the shorthand here. If you hover over it, you can see where it's coming from anyway. And now I just want to add the positioning of the sprite. So whenever we create a button at the mouse position here, we want it to pop up there at the center of the mouse. So not the top left corner, which it usually is with SFML. We want to center it on the mouse. So we'll call this shape.set position. Makes sense, right? And within here, we could do mouse pulse view.x and mouse pulse view.y, but that's not what we want. That will put it on the top left corner. What we want is to put it at the center. So we're going to have to do some minus doings. Now, if you do some subtraction with something, it will move to the left and more to the top. So I'm going to subtract this with half of the width of the button, which we should now have, because we set the texture to it. Remember, a sprite doesn't really have a width and height until you put some kind of texture on it, or you specify the bounds from before. A rectangle shape might have, because it has some form of a shape at start. It doesn't need a texture, it can have a color. But a sprite will need a texture, and that will decide the size of it. So once we subtract the half of the width of the button, it will center it. So we'll say this shape.get global bounds, which is a very powerful and nice function, because you can get the positioning and the width and the height and everything. And you can get intersect. You can check if this bounding box is intersecting with another one, which is really nice. So it's a really good function. But in this case, I want the width for the x. Of course, we want to divide it with 2.f. I'm using floats because they're cheap and they're good. And all these other ones are in floats as well. So we want to keep that the same. And I'm going to copy paste this here. Remember, the copy paste stuff is always good. And now I just have to change this to height, and we'll center it. And you'll see it being centered when we start testing. But to do that, we need to flesh this out, and we need to flesh out the main function. So now when we create a button, it will be centered. It will have a texture or a color if you want, but we'll just go ahead with the texture, and I'll show you how it looks with the colors as well at the end of the video. Let's do the easy ones first. To get is pressed, well, all we have to do is to return this button state equals pressed. So if the state is pressed, well, we'll get true. If it's not, we'll get false. And the same for hover. So we'll do hover like that. And there you go. And the rendering part is really easy. We'll say the target we want to render to. So in our case, will be the window. That's what we'll send in here. And then we'll say draw this shape. Super simple. So in this case, now the big boy is the update. This is going to handle the input and the mouse positions and a bunch of things that we need for the button to work. So all that code will be in here. So let's just get started. Why wait around? So the first thing we're going to need in our case is to know where the mouse is, just to know if we're clicking on the button or not. Because if we don't know where the mouse is, we don't know where the click is happening. So to find that out, we're going to have to do a vector2f for the mouse position. And I'm going to call this mouse position view. And what I could do here is I could say SF mouse, which is a really nice functionality. And I can just get the position of the mouse here. But what's happening? It's red. Well, the get position sends a vector2i back. It's an integer. So why is that? How are we going to do that? Well, instead of making this an I, we need to understand how the mouse positioning works. Now, there are a bunch of videos on this, and I'll make more videos on this, so I'm not going to go super in depth. But basically, when you get the mouse position, it's going to depend on what you're looking for. If I were to have this window here in a game, you know, there's a screen, first of all, and then there's the game window, and then within that window might be a camera, which is panning around and moving around. So there are 3 different layers here. Do we want to get the mouse position relative to the window or the screen? So it doesn't matter where the window is. 0, 0 would always be the top of my screen. Or do we want to get 0, 0 at the top of the window, for example? So if this were the window here, 0, 0 would be here, not here. That would be minus. So 0, 0 is here. And then we have to specify the window in here. So we want to tell SFML, well, I want the window. And the thing is, in an SFML window, there's always a view, there's a default view. And a view, you can just think of it as a camera, simple camera, but it's just static. It's just like where the window is. It's always just the same perspective, same way. So we're not changing the view in any way, but it's right there. And we want to somehow get our mouse relative to that, because in the future, when you're working with games and mouse positions and stuff, you're mostly going to work with the views. Usually you want to have a camera somehow moving around in a game, right? So knowing that from start is going to help you out a lot. We wouldn't have to do it that way here. We could tricks and work this out in a way where you can use this vector2i instead of the f. But I don't want to show you that. I want to show you the half-assed version, right? In this case, at least, because it will help you later. So let's just go ahead and get the view position, which you will understand later as well, but just know how to do it. So the window has a function called map pixel to chord, okay? And it's a little complicated. You can read about it here, but basically it's saying it will transform the coordinates in a way where it will just work with your view. And you can map it depending on different views as well. So you might have 2, 3 different cameras. You can get the position relative to any of those views. But for us, we're just going to use the default view. So I'm going to map it to the default view, use the default view of the window, and I'm going to map this mouse position relative to the window and put that in there. And that will map the chords magically into a vector2f. And now we have a perfect mouse position. And don't think too much about this. I just wanted to give you some words on it so you know what it is. Now, the next step is to see if the mouse is actually targeting any of these or the button itself. So if this shape.getGlobalBounds, like I showed you earlier, has a contains and an intersect. So I'm just going to use contains. That is for a point. Intersects, it will check against another bounding box, but contains will check if a point is within the bounds of this shape. And we have our point now, which is the mouse point. So mouse post view. So if it is within this, we're going to do a bunch of stuff. And a lot of our code will be included within this if statement. So the first thing we want to check if it's hovering, well, the mouse is touching the button, so it will hover. So this button state equals hover. And we also want to change the texture to the hover texture. So this button or this shape dot set texture, this button, text hover. Sorry, my brain is all over the place. So we're setting it to the hover texture and we're setting the state to hover. Now we can do more than just hover on the button. We can press on it as well. So if we press the left mouse button, SF mouse is button press, SF mouse left. So if the left mouse button is pressed, then we want to click on the button. So this is very simple. I'm going to copy the code from our top, put it in here, and I'm just going to change this to text press, and I'm going to change the state to press. Good. So there we go. Now, if we're not pressing the button, I'm going to add an else statement here and paste this here as well. Then we're going to change this to text idle because it's not being pressed, and we'll set the state to idle. I'm just going to add a bonus extra fun thing here. I'm going to say if you right click on a button, you can move it around. So I'm going to add an else if and copy this code here. And instead of left, just say right. So if we're pressing the right button, well, what's going to happen? We're going to move it around. So we're going to copy the set position from up here and just paste it in here. Perfect. So now we're going to be able to move the button around if we just hold the right button down. And this is our update function. So just quick recap, we're getting the mouse position relative to the view within the window. So it's perfect. We get a vector2f. We're using that to check if the button has the mouse within its bounds. And then we're doing stuff. So we're hovering. And if while we have the mouse within the button, we press the left button, it will switch to press. Or if you're clicking the right button, it will allow us to move the button. Otherwise, we'll just set the texture to idle. So the button will be in the state idle. Perfect. So now we have our button class and now we can start playing around with that in the main function. So the main function is also going to be a little hefty, but we're just going to start easy here. We'll start with all the variables we're going to need. And this is going to contain some more C++ knowledge here. It's a little harder, a little more complicated, but try not to get stuck on the C++. Just copy what I'm doing and try to understand what's going on. I'll explain it. If you don't really understand it, take your time, try to learn that, and it'll be good for you to at least see it here. So first of all, to do anything, we need a window. And I'm going to create a SF render window, and I'm just going to name it window. Now, what's happening? We're not seeing anything here. Well, that's because we need to include Button.h. And Button.h contains all of these includes, so they will come in through that class here into our main. So we don't have to re-include that. And I'm going to remove IOStream. And the window itself is going to have a title. So we're just going to name this Button app, and we're going to give it a video mode. So that means how big the screen will be or the window will be. And of course, more settings than that, but we'll just use it for the size of the window. And I'm going to say 800, 600. Should be enough. You can put any size here you want, but here that will be enough for us to see what's going on. And I'm going to create a container using something called a vector to contain my buttons, because we're going to have multiple ones. If you just want to have one, you can go ahead and create one button, but we're going to have several, and we're going to be able to add them and add many of them. So we're going to need a vector. So I'm just going to include a vector. Great. You don't have to put this above button if you didn't know that. I just usually like having my custom classes below any standard template library stuff. So just do it like this if you want, perfectly any other way as well. So I'm going to do a std vector containing buttons. Who could have guessed? I'm going to call this button vec. Now, one issue here, which I really want to highlight. So make sure you're listening now. Really importantly, okay? Let's backtrack just super quickly. If we go into our Button.cpp, what you're seeing here is that your textures are within the class itself and they're being loaded in the constructor, but there's no support for them really being copied. So the thing is, if you had created these outside and used references, you wouldn't have had this issue. But in our case, what will happen is that the default constructor will be called, if we create buttons here, and we'll try to copy over any new buttons in here. There'll be copying going on in the background in the vector, basically, and it will kill that texture, so it'll be gone with that copy. If you're using references and you're doing stuff like that, you won't have that issue, like I said. But here, in this case, when we create a bunch of buttons into this button vector, it will just completely destroy that. So what we need to do is we need to create a button pointer vector instead. So there will just be button pointers in. If you haven't worked a lot with button pointers or just pointers in general, if you haven't worked with that, I know it's going to be a little confusing to you, but just like I said, try to follow along, try to learn about pointers, and you will just be super happy that you did. But I'll try to explain this as best I can. Buttons pointer in this case won't be a button or defined button. It will just be waiting for a button. Just something that will get assigned the address of the actual button that's created later. So to not confuse you further, I'm just going to go ahead and go with this, but just remember that this is a pointer now. We're going to need something called float key time, and this is to not add buttons super fast. So if you just press a button, it will continuously add a bunch of buttons for you. If you have key time, it will slow that down. It will allow us to maybe add one button per 5 seconds or something. So slow it down so we don't spam buttons as soon as we press. So firstly, we're going to add a key time max, and I'm going to say about 1000 F is a good time. Float key time equals key time max. So we're going to start off key time being at its max value. And whenever we set this to 0, we're going to add 1 to key time, so it goes up to 1000 again. So we can only add something when key time is at 1000. If it's anything less, we won't be able to click a button and add something new. So it's going to limit that for us. You'll see that in just a second. Now we're going to add the start of the game loop. So while our window is open, great function to have, we're going to do our game. Everything in here is our game loop. So a game loop is basically that you do something, logic, and then you render sprites, and then you just do it over and over again in a loop. So you update something, a position of a player, and then you render it to show you on the screen where it is, and then just every frame it's the same. So firstly, in our loop, what we're going to do is we're going to add some kind of event handling. So without this, you won't be able to close the SFML window without terminating it through the task manager, for example. So you won't have a way to just click and close it. So we're just going to add that first. And this is all the same in pretty much every SFML project. So you just add an event, another while loop, and we'll poll for events in the window. So polling means you're waiting for event. Window.poll event. So any event that happens in the window, it will be sent to this variable. So we'll just keep it, and then we can use it later. So now we'll check what type of event might happen. So if an event happens with the type SF event closed. So this is basically when the window is requested to be closed, just like it says. So if you press the X button or something like that, whenever the window is closed, we'll exit the game by closing the window. So if you don't do this, it won't actually close the window. But once you close the window, the process exit. So this will allow us to close our window. Pretty sure if I start this now, we have our button app window and I can close it perfectly. So the next functionality I'm going to add is to add a button to the screen. I'm going to copy some code here since we're going to need to use that. So I'm going to copy this and a little bit of this if statement, and I'm going to just paste it here. So we're going to use the same variable. So get the mouse position view relative to the, mouse position relative to the view. And then we're going to check for a button press. So to add a button, I'm going to use the B button on the keyboard. SF keyboard is key pressed, and within parentheses, SF keyboard B. So this way we can check if the B button is pressed. Now remember, if we use this, well, it's going to spam B so hard that we're going to create a billion buttons in a millisecond. So that's why I need to use the key time. And the only time I can add a button is when I press B and key time has reached its max value. So not this, just key time equals key time max. And we're going to add an and here. What you could do to save it is to add a, what the hell is going on? What is greater or equal to? There we go. So in any case, if key time would go over key time max also is fine. It won't because we're adding it by 1, but if it would do, then it will still work. And here is where we add the button to our button. So button.vec.pushback button mouse pause view. Now what's going to happen if I do this? Well, it's going to complain. Why? We need to not just add a button, but it's a pointer to a button. Obviously, this is not a pointer. This is an actual button going in here. We need to give a new keyword. So we're creating a new button, placing it somewhere without a variable name, and we're asking the pointer that is at that position to point to that place in the memory to this position. But what this has us do later is to actually delete these buttons so that you don't create memory leaks. Because if you forget to delete dynamically created data like this, you'll create memory leaks. It won't do it for you. If it's a static button, it would have just handle everything on its own, but it's not. So we're going to have to do that later. So once we push this back, we also want to set key time to 0 because we don't want to add another button directly after. So as soon as it's 0, it won't allow us to add one more because of this part here. Now, if you remember, we had a update function, which actually checks for the logic of the clicking of the button and everything. So of course, we want to add a way to do that. Now, since we have a bunch of buttons, we need a for loop. So I'll just make a default for loop and I'll loop through all of the buttons in the button vec. So button vec.size, which is a function. So now we'll loop through all of the buttons. If you're on newer C++, you can use a for each loop as well. They're more efficient. I will say button vec at the position I update, and that requires the window. So we're just going to say the window like that. Good. Next is we want to update the key time because if we don't, it will be stuck at 0 and we can't add more buttons. So we actually just need to increment key time by 1 each frame. So I'm going to go ahead and do that. I'm going to say if key time is less than key time max, I'm going to increment key time. So key time plus equals 1.f. Simple. So this is all we need. Now we're at the final stretch. We just need to render here. So how do we render all the buttons? Well, we need a for loop. But firstly, we need to clear the window of the previous frame. So window.clear, and then we're going to do window.display. And that just pushes everything we've rendered to the screen. So these two are real important. Each game loop always clears the previous frame and it adds whatever it adds, it sends to the window at the end. If you don't do display, it's not going to send the new frame to the screen or to the window. You need to explicitly tell it to display whatever you've rendered. So just do this, but in between, we're going to render the button. Now it could be a good idea to comment here. So this is the render part of the loop. This is the game loop, and this is the update part of the loop. So it's a little easier to see what's going on. I'm going to add another for loop here. The reason we can't use the same for loop for rendering and updating is because we need to do all of this stuff as well. And we want to split them up. Usually it's more important to have readability than to have one for loop. So I know it's double, but in this case, it's fine. So I'm just going to say render here instead and to that window. Now this still works, even though we are asking for a render target, it still works to send in window because it derives from a render target. So perfect. That way we're rendering all of our buttons and we're displaying it. Now the last thing I want to do before starting this would be to delete all the buttons I created at the end of the loop. So if you see, this is the game loop right there. So if the game loop is over, the window is closed, that means we're not playing anymore. That means we can clear up any memory we've allocated with new. So I'm going to do a for loop again, and I'm just going to say delete all of the memory we've allocated that the button vec is pointing. So perfect. Just go ahead and do this. Don't forget to do this. Otherwise you'll have memory leaks, but this is fine. Good. Now we are pretty much done. Let's click the holy button of debugger and let's see what happens. Boom. And I can click B, press B, and I'm adding a bunch of buttons and they're hovering. And I'm clicking and they're clicking, and I can right click a button and I can move around. I can position them as I want. I can click them just like that. So hopefully this worked for you guys and you're getting the texture as well. Everything's working fine. If not, just drop a comment and we'll try to figure it out. I just want to show you how to do this if you don't want to work with sprites and the textures. So if you just want to try this out with colors, that's why I added the colors here. So I'm going to change the sprite to a rectangle shape like that, and that will turn a few things red. In here, firstly, I'm going to have to comment out any of these set textures, and we're going to have to give a size to our new button, shape.set size sfvector2f, give it a size of 100 f and 50 high, and then a color as well. So we're going to set the fill color to the idle one at start, this color idle. Just copy this one with you, and we'll comment out all of these ones where the texture is being set, and instead we're going to give it a color. So this is hover, and when it's pressed it would be pressed, and idle would be idle. Now let's run this, and now you will see a few buttons with colors instead, and you can click them just like you could before. It's a little different, but this works if you don't want to bother with the textures and just try this out anyway. So hopefully you enjoyed this part and hopefully it was helpful, but I'm going to remove anything I did with the colors, and the code you'll find on GitHub will be with the textures. Well, at least you've seen how that worked here. So thank you so much for watching, guys. Hopefully you learned something. Hopefully you enjoyed the video. It was kind of a very basic video, not the best explanations and all that, but you guys know me, that's how I roll. But like I said, check out my other tutorials. Drop a like, subscribe. It really helps me out. It really makes me keep making these videos. That would be the main reason I would continue doing this. So please drop a like, comment, subscribe, and just let me know what you'd like to see when it comes to these simple types of videos, because this is pretty much what I have the time to do with the work and the family. And I still enjoy making these videos and helping you guys. So please let me know and take care. I'll see you in the next one. Bye-bye.